Thank you for joining me today. We will continue how to calculate the quantity takeoff for the concrete work. It's very important to understand the concept of volume. If you would like to figure out a volume for any body, you have to remember this cylinder, the volume of this cylinder equal the area of this cross section time this height where your cross section is constant. Your cross section is the same, is the same, is the same, is the same. So if you calculate the area of the cross section time the height, you can get the volume of this cylinder. The same concept for everything. For example, if we are talking about a slab, your slab will have area and this slab will have thickness. Exactly like this example. This one. You have a slab and this slab has an area which is length by width. And this slab at the same time has a thickness. The same idea like cylinder. You have this slab with thickness. So if you are able to figure out the area of the slab, this area is constant throughout the thickness of the slab, then the volume of concrete to be used to pour this slab equal area time thickness. That makes sense? This is for slab. Sometimes your slab is connected to beams. So the volume of slabs equal area of slab. You can find the area from the drawing time thickness. Sometimes this slab is connected to beams. In general, your beam looks like this. So if you would like to figure out the volume of this beam, you have to understand the concept. We will figure out this area of the cross section. This is called cross section of the beam. Will be labeled like B times T. So if you multiply B by T, this is the area of the cross section. And this cross section is constant throughout the length of your beam. So if you multiply this cross section area by the length, be careful about the units. All of them must be the same. All of them inch, all of them feet, all of them meter, millimeter, whatever. But all of them the same unit. You can figure out the volume of your beam. But be careful if you have your beam alone, we will do this. But be careful if this beam is attached to slab, like this one. We have a slab and we have beam coming out from this slab. Does that make sense? So if you would like to figure out the volume of the slab, I will multiply the area of the slab times the thickness to figure out the volume of slab. This is what we learned here. Area of slab times the thickness. If you would like, make sure and be careful in this calculation, you already calculated the volume of this part of concrete. That makes sense? So the remaining part regarding your beam will be this part only. To figure out the volume of beam, you need to multiply this area by the length of the beam. That makes sense? Don't count this part one more time with the beam because we already counted it with the slab. That makes sense? So the cross section will be given like this. And this total dimension is given, for example, 30 inch. And the thickness of the slab is given 6 inch. So the part of the beam that will be counted is only this part. For example, this one is 12. So it will be 12 inch by 24. Because the above part of the flange is already considered in the slab volume. Does that make sense? Also, if we are talking about, let me do example for the slab and the beam. We have example here. This one. We are given a solid slab. So keep in your mind, this is called plane. If you look to the floor from the top, you will find this is the plane, just the area of the slab. And we are given two double lines. Can you see the double lines? Parallel to each other. These two double lines represent that we have a beam at this location. So if you look from the top, I will see these two edges of the beam like two parallel lines. This is a beam, this is a beam, this is a beam, and so on. We would like to figure out how much quantity takeoff of concrete to pour this solid slab. Keep in your mind, we will divide your calculation to two parts. The first part for slab. Easy calculation. What you need only to figure out the volume of the slab is the area of the slab times the thickness. Area of your slab can be figured out from the plane. And the thickness of this slab can be figured out from the cross section. We are given a cross section for this slab. The thickness equals 6 inch. And the area of this slab, so the volume, equal area time thickness. The area of this slab, you have to read your dimensions carefully. This total length from here to here looks like around 50 feet. And the total distance from here to here looks like 1, 2, 3, 4 tens. So it will be 40 feet. So the area of this slab will be 50 feet. I'm sorry? Do you have any question? So it will be 50 feet by 40 feet. This is the area of your slab, and you can figure this out from the plane of the slab. Time the thickness. Your thickness of this slab maybe is given, or you have a cross section showing the thickness of your slab 6 inch. We have a little mistake here. We cannot multiply feet by inch. So I have to convert one to the other one. So I will convert the 6 inch to feet by dividing it by 12. So the total volume of concrete slab, just for a slab, equal 50 times 40 times 6 divide 12. I got 1,000 cubic feet. If you would like, I will divide it by 27 to convert it to 37, almost 37 cubic yard. Four beams. Keep in your mind, if you would like to figure out the volume of your beams, you have to multiply the cross-section area of your beam times the total length of this beam. And be careful, if your beam is attached to the slab, this part is already considered in the slab. So I will count the beam just below the thickness of your slab. So your cross-section of the beam is not this one. This is not the cross-section of the beam. This is not the cross-section of the beam. If you do this, that means you counted this part 2 times. One with the slab and right now one with the beam. So I will consider the cross section of the beam is 12 times, not 30, it will be 24. 30 minus 6. So the volume of your slab equal area of cross section time total length of beams. So the volume will equal cross section will be 12 inch times 24 inch time total length. 12 inch by 24 inch. This is the cross section area of this slab. Anybody can help me to figure out the total length of these beams? What do you think? Keep in your mind the length of this beam equal 25. The length of this beam 25. The length of this beam 25 feet. 25 feet. 25 feet, because each double line represents the beam length. This is the length of your beam. 25 feet, 25 feet, 25 feet, 25 feet, 25 feet, and so on. And we have 10, we have 10, we have 10, we have 10, we have 10 feet, 10 feet, 10 feet, 10 feet, and 10 feet, 10 feet, 10 feet, 10 feet. Go ahead and add all of these dimensions together to find out the total length of your beams. That makes sense? So I will multiply 25 by how many? 1, 2, 3, 4, 5, 10. Plus 10. 1, 2, 3, 4, 8, 12. So the total length of your beams equal 370 feet. This is called the total lengths of beams. Just from the plan of the slab, you can figure out the total lengths of these beams. Anybody has any question regarding this point? I cannot multiply these three numbers together because all of them has different units. So I will divide this by 12 to convert them to feet. So
Is the 370 right?
I'm sorry?
I wasn't sure if the 370 was right.
Is it wrong?
Oh, never mind. I'm sorry. I counted too many 25-foot links. Never
Yeah,
mind.
yeah. Go ahead. Just mark after you count 1, 2, 3, 4, 5, 6,
I counted.
7, 8, 9, 10. So we have 10 times 25 feet, it will be 250. And your
Okay.
10, 1, 2, 3, 4, and we have 8, and we have 12. That makes sense?
Yeah,
Okay.
I got it.
Yeah.
Thank you.
Thank you. So the total will be 1 times 2 times 370 equal 740 cubic feet. If you divide it by 27, I got 27.4 cubic yard. Keep in your mind, I will pour this concrete at the same time. When you are pouring a solid slab, your floor slab, I will pour all of them at the same time. So beams and the slab at the same time. So the total volume of your concrete to be ordered equal this number 37 cubic feet, cubic yard, I'm sorry, plus 27.4 cubic yard. So the total will be 64.4 cubic yard. I need to call the concrete company to order this amount of concrete to pour this concrete slab. And based on the information here, no need to consider any waste factor. So I will not increase this amount, just order it. Okay, so probably the company will say each truck of concrete can support or can carry only 6 cubic yard. So how many trucks you need to order? probably I will order 11 trucks. Does not mean we have 11 trucks, but the truck will deliver the concrete by 11 times. Anyway, it's not our deal right now, but so far the total volume of concrete that needed to be ordered 64.4 cubic yard. Keep in your mind this concept, how to figure out the volume of your slab, how to figure out the volume of your beam, and be careful. If you have a beam attached to the slab, don't count this part 2 times. Also, keep in your mind, we have sometimes footing. Your footing looks like this. In the real life, in the 3D, looks like this. This footing consists of length, width, and thickness. So if you would like to figure out the volume of this footing, we need to multiply the length by the width by the thickness. This is thickness, this is length, this is width. If this footing is repeated many times in the building, so we have to multiply this volume by the number of footing. Does that make sense? For example, this one. We are given 9 footing. 1, 2, 3, 4, 5, 6, 7, 8, 9. Each is a square footing with dimension 6 by 6 by 1 feet thickness. So if you would like to figure out the volume of footing only, I need to multiply the length by width, 6 by 6. You are lucky because the footing is a square. By thickness, the thickness is given in this sketch equal 1 feet. Your unit is okay. Time the number of footing, how many footing in this plan is 9 footing. So if you multiply these numbers together, this is the volume of 1 footing. This is the number of footing in the plan, in the building. 6 by 6 by 1 by 9 will equal 324 cubic feet. If you divide this number by 27, I got 12 cubic yard. Does that make sense? That makes sense. So I need to order 12 cubic yard, but we have information here. You have to consider 10% extra for wastage. So if after considering the wastage, you need to order 12 by 1.1, 10% extra. So I need to order 13.2 cubic yard. Sometimes you are given footing with different sizes. So in this example, for example, we have F1, F1, we have F1, we have F1. These footing only are 3 lengths, 3 width, and 20 inch thickness. We have another footing, which is F2. This one is alone, F2, equal 5 feet length, 5 feet width, 20 inch thickness. We have F3, this is F3. This F3 is 4 by 4 by 20 inch. And we have the last one, F4, F4, F4 repeated 3 times. This F4 2.5, 2.5 times 20. So we have to consider the volume for footing F1, the volume for footing F2, the volume for footing F3, the volume for footing F4. As I told you, the volume of one footing equal length by width by thickness by number. F2, length by width by thickness by number. How many? F3, 4 by 4 by 20 by number. F4, volume for footing F4, 2.5 time 2.5 time 20 by number. We have little mistakes here. This 20 must be divided by 12, divided by 12, divided by 12, divided by 12 to convert it to feet because it's in inch. Second, F1 is repeated how many times? 4 times. F2 repeated 1 time. F3 repeated 1 time. F4 repeated 3 times. So we have 9. If you submit, if you get the summation of this volume, your summation will be something like how many? How much? 3 times 3 times 4 plus 5 times 5 times plus 4 by 4 plus 2.5 times 2.5 times 20. I think I got 159.6. If you divide it by 27, it will be around 5.9 cubic yard. Let me check it one more time. I'm sorry. 3 by 3 by.
Yeah, that's what I got as well.
It's good.
Yeah,
Thank you. Thank you so much. And looks like we have 15 percentage extra for wastage. So I have to multiply the final volume will be 5.9 times 1.15 for 15% extra. It will be 6 point something, 6.8 cubic yard. So I need to call the company to order 6.8 cubic yard to pour just the 9 footing. So the final conclusion, if you have footing, you need to multiply length by width by thickness. Be careful about the unit times the number of footing. Sometimes the number of footing for all of them, because all of them the same size. Sometimes we need to repeat this calculation for each size. Keep in your mind, we have columns. Your column in the real life looks like this in the 3D. The same idea. If you would like to figure out the volume of this column, you need to multiply this cross section. What is the length? What is the width? Once you get this cross section is the same along the height or the length of this column. So the volume equal cross section area time the length or the height of this column. Actually, we need to multiply it by how many columns do you have? Does that make sense? How many columns do you have in your building? For example, in this case, how assume we will continue in this example. This column is given by 20 inch by 20 inch, and the height of one column equal 10 feet. We are given this information here that each column over this each footing, each column is 20 inch by 20 inch cross section, and the height or the length of this column 10 feet. So I can say the total volume for columns equal 20 inch times 20 inch. This is the cross section area times the height of one column, 10 feet. How many columns we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9 columns. So I will multiply it by 9. But this is the number of columns. But be careful, we have little mistake here because this 20 is inch and this one in feet. So I will divide this by 12 by 12. So the final volume of your columns will be 20 times 20 divide 144 times 10 times 9, I got 250 cubic feet. If you divide this number by 27, I got 9.3 cubic yard. So if you would like to pour, just to pour the footing, you need to order 6.8 cubic yard after considering the wastage, 15%. If you would like to pour, just to pour the columns, you need, just a second. Yes, we are good. You need to order 9.3 times 1.15 to consider the wastage. So I need to order 10.6 cubic yard. This is the actual volume of concrete we need to build up or to construct your columns. However, we should expect some wastage. We should expect some damage in concrete during pouring, during construction. So we have to order extra a little bit to avoid any shortage during the construction. So the final conclusion, as a contractor, you can build up your cost estimation based on this amount, these volumes. Because if you called the company of concrete will tell you, hey, 1 cubic yard will cost you around $200. So if you would like to order 6.8, you can understand 6.8 will cost you how much. That makes sense? If you right now, if you call any concrete company, any concrete plant, it will tell you, hey, 1 cubic yard concrete will cost you for delivery for everything around $200, 250, 300, whatever. Then you have the amount, how much volume. If you multiply this number by this money, you can get the total cost of concrete as a material. I did not consider the worker, I did consider any equipment, vibrator, or anything else, but just material. Does that make sense? Sometimes your element is wall or retaining wall. Both of them the same meaning. Wall or retaining wall. The typical wall we understand is something like this. I would like to construct for example, fence, concrete fence. I'm saying concrete. It's not brick. It's not bricks. It's not wood. It's concrete wall. So if you would like to figure out the volume of concrete needed to construct this wall, same idea. What is the area of this cross section, which represented by the height of the wall and the thickness of your wall, and multiply this area by the length. So I can tell you, hey, I would like to construct a concrete wall. Just a few sentences. Concrete wall with thickness equal, for example, 5 inch and height equal 6 feet with a total length equal 100 feet. So you have to understand what does it mean of this information. The thickness of your wall is this one, 5 inch. The height of your wall is this one, 6 feet. The total length of your wall is this one, 100 feet. So if you would like to figure out the volume of concrete required for this wall, you have to multiply 6 feet the height by 5 inch the thickness, this is the area, by the total length 100 feet, you can get the volume. Be careful to divide this thickness by 12. So the volume of wall equal height time thickness time length. That makes sense? Sometimes I will say, hey, I would like to construct a wall with thickness equal 4-inch concrete wall, with height equal 8 feet around the shown property area. I have area of land looks like this. And I would like to construct a wall, concrete wall around this area of land. So I need to construct a wall with this length. Does that make sense? That makes sense? So you are given the thickness. You are given the height of the wall. What is the length of your wall? Any help? What will be the length of your wall? Don't give me a number, but just tell me the concept. What will be the length of your wall?
Yeah, the total width.
It's not total width, it's the total perimeter of this area of land. Total perimeter. It will be this side length plus this one, 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 plus this one. Because your wall will go around this area of land. So the total length of the wall will be equal or will equal the total perimeter of this area of land. Sometimes your wall is called the retaining wall. In this case, your retaining wall looks like a vertical wall with a base like this. And all of this cross section is extended for a length. Like this. This is called retaining wall. It's a wall, but the wall and its base, both of them, one unit. The same idea, if you would like to figure out the volume of this retaining wall, I will figure out the area of this cross section. What is the area here? You can divide it to many parts, 2 rectangles, 3 rectangles, whatever. Then you need to multiply this area of the cross section time the total length of your wall. Time the total length of your wall. You can figure out the volume. We have example here. This one. We are given a retaining wall with a total length equal 100 feet. And this retaining wall taking this cross section. I don't care about anything inside this cross section. It's not our deal right now. Does that make sense? So keep in your mind, these units are in feet, yeah, I believe. Keep in your mind, the width of the wall at the top is 1 feet. At the bottom, this one is going like this. So the width at the bottom is 1.5 feet. How did you know? This one, 1.5 feet for this width. So we are given this. 1.5, 1.5, 4 feet. And this thickness is given 1 feet. And the total height here is given, I think it's 2 plus 8, it's 10 feet. Does that make sense? So if you would like to figure out the area of this cross section, I think we cannot do this one time. We have to divide this cross section to many parts. The first part is this one. So the area of this part will equal, I think 7 feet times 1. equal 7 feet square. The second area, which is the area of this one, I think it's a trapezoid. So we can say 1 feet plus 1.5 feet divide 2, this length plus this length divide 2 times the height in between, which is 10 feet. So I can figure out the area number 2. So it will be 2.5 divide 2 times 10. I got 12.5 square feet. So the volume required of concrete equal the area of this cross section, which is 12.5 plus 7. This is the area. This is the area in square feet. Time the total length of this retaining wall is 100 feet. So I can figure out the total volume. It will be 1,950 cubic feet. If you divide this number by 27, I need to order 72.2 cubic yard. Too much. Too much. Does that make sense? That makes sense. Any question so far? We have one more example here for the slab. We can do it if you want. We are given solid slab. So we need to figure out the volume of slab itself and the volume for the beams. For the volume of your slab, I think the area of the slab times the thickness. The thickness is given here. Can you see it? From the cross section. Thickness of the slab cannot be shown in the plane. Must be shown in a cross section. It's a 4-inch. So the area of your slab will be 30, 32, be careful, 30. So the total length is 92 feet. This one is 15, 15, 15, 15. So the total will be 60. So the area of the slab from the plane equal 92 feet by 60 feet by your thickness 4-inch. We have a little mistake. This 4-inch must be converted to feet. So I will divide it by 12. Be careful about the units. So I have 92 times 60 times 4 divide 12. I got 1,840 cubic feet. I will divide this number by 27. It will be 68.1 cubic yard. This is just only for slab with a thickness 4-inch. If you would like to figure out the total volume of beams, we need to figure out the cross section of your beam times the total lengths of beams. Don't count your cross section of the beam 1.5 by 2-inch by 2 feet. This 1 feet and the 6-inch means 1.5 feet. This one is 2 feet. We have a mistake here. Because if you consider the cross section of your beam 1.5 times 2, that means there is a part here. This part will be counted 2 times. That means your calculation is not accurate. That means if you did this, you will order extra concrete. By the end of the construction, you will find much of concrete still available, which is not good because more material means more cost, which is useless. So the cross section of beam that will be counted will be what? This cross section, the total is 2 feet, which is 24-inch. If you subtract the thickness of your slab 4-inch, so the remaining will be 20-inch. So I have 20-inch times 18-inch. This one is 18-inch. So this is 18 and this is 20. by 20 inch. I will divide it by 12 and 12. time what is the total length of your beams. What is the total length? We have here, this is 30, this is 30, this is 30, 30, 30, 32, 32, 32, 32, 32, 30, 30, 30, 30, 30, and we have 15, 15, 15, 15, and this 15 repeated 4 times. So the total length will be 15 times 4. This is the total length 60. Repeated 1, 2, 3, 4 times plus 30. Repeated how many? 2, 4, 5, 10 times plus 32 is repeated how many? 5 times. So the total length of this beam 700 feet. If you have any comment, let me know. The total lengths of these beams, this one plus this one plus this one plus this one plus this one, and so on, equals 700 feet. If you multiply this total length by this cross section, I need to order 1,750 cubic feet, or divide 27, 64.8 cubic yard. So the total volume of concrete that needed to be ordered equal 68.1 plus 64.8. It will be around 132.9, too much cubic yard. We have a very huge concrete slab, 132.9 cubic yard. Any question? Guys, do you have any question? I have one more example here, but this example is plain solid slab, and this solid slab has a thickness equal to 100 millimeter. Be careful, the units right now, millimeter, meter, centimeter. And your beams is 250 times 70, times 700, I'm sorry, 250 times 700. Your cross section of the beam looks like this. I'm giving you this width, 250, and this total thickness is 700. And the thickness of your slab is given by 200. So if you would like to figure out the volume of the slab, we need to multiply the area of this slab by thickness. That's fine. Your thickness is given 200 millimeter. What about the area of the slab? This is your drawing purpose. I need to figure out the area of this shape. Can you look? I need to count what is the area inside this blue line. But I need to subtract this area. This area is void. We don't have a slab here, it's a sky. So we don't have area here. So I need to subtract this area. I'm sorry. Actually, if you have this drawing, and you should, if you have this drawing on AutoCAD, AutoCAD in 1 second can tell you what is the area inside this blue line. I can figure this from AutoCAD. Exactly, in 1 second. But we should have this drawing on AutoCAD, and I believe as a contractor, you will have all drawings as electronic format or AutoCAD files. So you can open the file using AutoCAD and figure out the area by, there is a command called area on AutoCAD. So can tell you what is the area. If you multiply this area by this thickness, you can get the total volume. But be careful, your area, I believe it will be, must be in square millimeter, or you can convert both of them to meter. It's up to you. Otherwise, if you don't have AutoCAD file, otherwise go ahead, I'm sorry, you are given these dimensions. So you can figure out the total length here, and what is the total width here, and you can roughly figure out the area of this slab. This is the only way. But just math to how to count the total area of your plane. For beams, volume for beams, the cross section of beam that will be counted only this part. So I need to multiply 250 by 500. 500, yes, because this part will be 500 after you subtract 700 minus 200, because this part is already counted in the slab. Then I need to multiply the cross-section area, this area, by the total length of beams. Go ahead and figure out the total length. What is the length here? This one. What is the length here? This one. What is the length here? This one. What is the length of this beam? This one. What is the length of this beam? It will be the same. The same. The same. What is the length of this beam? You can get it from here. So with your calculator, go ahead and tell me what is the total length of these beams. You can figure out this number. Just you need some time. And I do recommend after you counted a beam length, just mark it to don't be confused. So I will put on my calculator, for example, 3,825. So I counted this one. If you would like to count this part, so I will add 2,800. If you would like to count this one, I will add 3,325. Plus, if you would like to count this one, so I will add 3,205. If you would like to count this part, I would multiply this one by 2, the previous one, or add another 3,205, and so on. By the end, equal will give you the total length of your beams. That makes sense? But the same idea. The same idea. Whatever the slab is given, whatever. The volume of slab area times thickness. Whatever the beams are given, the cross-section of your beam times the total length of your beam. Sometimes your plan is easy, like this one. Sometimes you need to pay more attention and spend more time to figure out the lengths of these beams and add them together.